hi everyone, I'm your closing session today. I'm Matt. I'm a senior data engineer on the machine learning team at Shopify. And today I'm going to talk about how Shopify helped in scaling fees for BigQuery. So first, I'm going to give you some context about Shopify and a use case we use to onboard with fees. Then I'm going to talk about 4 problems and their solutions. This will go from window functions to skew join. And at the end of a quick conclusion. So let's jump into it. Shopify is active in the OSS ecosystem, the open source software ecosystem. In the data org, for example, we are users and contributors of Ray, Presto, DBT, Iceberg, just to name a few. We process terabytes of data. Every day, we have dozens of engineers working on machine learning problems. So all the problems we encountered and the solutions we put in place are tailored to tackle such a scale. Of course, the entire community can now benefit from it. We decided to go with Fizz for multiple reasons. First, it's plug and play, and so we could create our custom provider as well as online store. And Fizz helped us in handling the business logic like point in time, join, doing historical retrieval of features. Second, it's open source, and this is the kind of project we like to collaborate with. Last but not least, we had a great fit with William and the team, and we felt that we could collaborate with them to make Fizz better in the long run. Our first experience with Fizz was really successful on the toy data sets until we tried on a real use case. So let me present to you this use case. It's composed of 4 feature views and 2 entities. The relationship between drivers and rides, the 2 entities, is one-to-many, which is very important for the rest of the talk. So for example, we can see that feature view A and B are about 3.5 billion unique rides, and feature view C, for example, is about 1.1 billion unique drivers. When we need to perform historical retrieval, we often only needed to do it on a subset of the data. So for example, here, 100 million unique rides. The reason is like we don't need to train our machine learning model on all the data. And last but not least, the last thing important to understand is like those 4 feature views add up to 15 features. So if we recap, this use case about 2 entities, 4 feature views, 15 features, and billions of rows to process. So when we tried this with our use case for the first time, we ended up with many scaling issues and this type of errors, so out of memory errors. So let's walk into 4 of the problems we had and their solutions. The first problem was around how we were generating a unique identifier. So Feast needs to create a unique identifier of the rows of the entity data frame. And that was using row number over, which is window function. The problem is when you use a window function without a partition by, it means that you send all the data to a given worker. So the solution here was to compute our own UUID using like just a concat function. Here, but by concatenating all the columns that make a row unique, like the entity keys and the timestamp columns, we can retrieve the information at scale. Indeed, to perform this operation, we only need to be aware of the data of a given row. Because this entity data frame is a CTE used in many places, we need to have a function that is deterministic, as it might be computed at different places at different times. The second problem was a very small one, but basically we were outputting the results into a pandas data frame. As I'm sure you are all aware, pandas is in memory, and therefore we ended up with like a error. The solution here was simply to create a method to save the result of an historical retrieval directly in BigQuery. The third problem was a bit tricky, but basically we were performing historical retrieval on all the data whatsoever. So here, first, before we're performing historical retrieval on each feature view and then join the data back to the entity data frame, which means that if you only need a sample of your data, let's say an entity data frame containing 10 drivers, you will still end up performing the historical retrieval of all the data for each feature view. So as you might guess, the solution here is to do the other way around, to join the feature view to the entity data frame as early as possible. By doing so, on our use case, we ended up with consuming half of the resources than before. And last but not least, this problem is about like understanding your offline storage is very important. So BigQuery will optimize the query for you. It's important to understand where the heavy operations like join, group by, window functions happen. So for example, this is how our historical retrieval operation on our use case got interpreted by BigQuery. It ends up being pretty complex, right? So what we can notice is that the entity data frame is used all over the place and multiple times. Second, we could identify our 4 feature views in the red box here. What they have in common is that they are used 3 different times for join operations. And sometimes this join operation is directly with the entity data frame. So the problem we have with our use case is what happens when there are multiple entities that have a one-to-many relationship. Let's take again this example of drivers and rides. A driver can have multiple rides, let's say up to millions of them. We can see that the entity data frame is going to contain information about the more granular of the feature view. So here it will be about a ride, which means that a driver is going to be repeated over and over. So when we join the entity data frame with the feature views, there is no consequence for the ride feature view, but there is a huge consequence for the driver feature view. And because here in this example, driver 1 is completely overrepresented, this is what we call a skewed join. With this like tiny example, that will not be a problem, but at scale, that just can't run. So the solution is to pre-aggregate the entity data frame for each feature view before we join it. We can see, for example, on the left that the entity data frame for driver feature view completely shrink and only contain what's necessary, information about driver ID 1 and 2. On the right, it actually did not change much. We just dropped the driver ID column and then we perform a normal join with the right feature view. This fix is not available in Fist yet. It has been like pushed on the Shopify side, and now we are like trying to make it happen upstream. So because this fix has not been published in Fist yet, how do we use it? Well, first we have our own API using Fist. This is for 2 reasons. First, part of the implementation is really Shopify specific. Like we have our custom provider, custom online store. Second, we can manage the entire experience of our users much better. And then when we have this kind of issue, we can just like unblock our users and give feedback to Fist, the developers and the community. So for example, at the time of speaking, there is a PR up, but this is a draft PR and we still need to work on it to make it happen on the Fist repo. So let's jump to the conclusion. Because of the scale of Shopify, we could make historical retrieval using BigQuery scale to billions of records. Of course, the entire community can benefit from the work. But the real conclusion is don't be shy and contribute too. The core maintainers, like Willem and the team, are really receptive to ideas and contribution. And moreover, if you want to partner on a specific project, feel free to just reach out and other people might be interested to collaborate. On our side, what's next? We are really interested on end-demand transformation. So the ability to perform transformation during retrieval operation. So there is an RFC up that I contributed with Willem. Then we are really also interested in creating a Presto Iceberg offline store instead of using BigQuery. So if you are interested by this project, we could definitely collaborate together. So thanks for listening. I'm Delacour. You can ping me if necessary. Also, you can just ask your questions in the Apply conference channel. Thank you, everyone. And Dimitri, just take it over.